In this video, we're going to be talking about multiplying fractions in mixed numbers. When we're talking about multiplying fractions, we can think of this as finding a part of a part. So let me give you an example. Let's say that we have a circle, and we are asked to find half of a half of the circle. So we want to find half, that's 1 over 2, of a half, 1 over 2. 1/2 of the circle is right here. So that's this. And we are asked to find half of that. So I'm going to split it in half again. And that's this piece up here. Now you can see visually that half of a half is 1/4. But what we need to figure out is how do we show that mathematically. So we want to do 1/2 times 1/2. And in order to get our answer 1/4, what you do is you multiply the numerators. 1 times 1 gives us 1. And you multiply the denominators. 2 times 2 gives us 4. So let's try some examples. In our first one, we're asked to multiply the fraction 9/5 times 1 over 8. And if you ever see something like this is common to see, especially when you're dealing with fractions, something in parentheses and then a number right outside the parentheses. There's nothing in between them. That means multiplication. So you could have a little dot to indicate multiplication or this symbol to indicate multiplication. But if there's nothing there, it also means multiplication. So we're going to multiply the tops. 9 times 1 is 9. We're going to multiply the bottoms. 5 times 8 is 40. And we can't simplify that, so that's our answer. And this rule applies whether you're multiplying 2 or 3 or 4 fractions together. You multiply your tops and then you multiply your bottoms. So for this one, we have 1 times 5 times 6, which is 30. And then we have 3 times 2, which is 6, times 25 gives us 150. This answer can be simplified though. We could say 30 is 3 times 10, and 150 is 15 times 10, so our 10s cancel. So we have 3 over 15. However, 15 can be broken down into 3 times 5. That cancels. And we're not really left with anything on the top because we could also say that 3 is 3 times 1. So really there's a 1 on the top. And we end up with 1/5 as our answer. Now there's another way to approach this problem in particular that might have made this simplification step easier at the end. Rather than pulling out terms we could cancel after we got our fraction, we could have done that in the beginning. So 1/3, we really can't do anything about that. Same with 5/2, we can't really change anything about that. But 6 over 25, 6 is the same thing as 2 times 3. And 25 is the same thing as 5 times 5. So when we break up 6/25 to look like this, you see we can start canceling things. There's a 2 that cancels, 3 that cancels, a 5 that cancels, and all we're left on the top is a 1, and all that's left on the bottom is a 5, and we get 1/5. So it's just a matter of preference whether you like to cancel before you multiply your tops and bottoms, or do you like to cancel after? Both ways are correct. Okay, let's take a look at an example of multiplying mixed numbers. What you want to do in this case is convert each mixed number into an improper fraction. And we talked about this in more detail in a previous video, but the shortcut is to multiply the whole number and the denominator together, and then add it to the numerator. So 2 times 3 is 6, plus 2 is 8, and that's all over the original denominator. 1 times 4 is 4, plus 3 is 7, all over the original denominator. I see that 8 over 3, I could simplify that into 2 times 4 over 3. And then 7 over 4, I can't simplify that any further. So 4's cancel. 2 times 7 is 14 over 3. Generally, you don't want to leave your answer as an improper fraction, though. So we see that 3 goes into 14 4 times, and 4 times 3 is 12. We had 14, so we have 2 left over out of 3, so 4 2/3. Final example, let's look at if you have an exponent. So we have a fraction and we are raising it to a power, or we are squaring it. And I just picked 2 for our exponent, but you could have had a 3 there, you'd be cubing it. You could have had a 10 there, you'd be raising it to the 10th power. The process is the same thing. So what this means is 3 divided by 7 times 3 divided by 7. We're taking the same fraction twice. 3 times 3 is 9. 7 times 7 is 49. Another way you could have approached this is if you have parentheses like this, you could put an exponent on the numerator and the same exponent on the denominator. And then 3 squared, that's 3 times 3. 7 squared is 7 times 7. 3 times 3 is 9. 7 times 7 is 49. Again, just 2 slightly different ways to think about it, but you get to the same place.